Welcome back to You Revise, where we talk about everything exams. Let us take a look at question 13 from the 2017 exam. It reads, consider the following reaction sequence. Step 1, hydrogen peroxide reacting with iodide ions to produce water and the iodate ions, and hydrogen peroxide reacting with iodate ions and then producing water, oxygen, and iodine. At same temperature, step 1 consumed H2O2 or the hydrogen peroxide at a rate of 4.55 times 10 to the power 22 molecules per second, and step number 2 consumed hydrogen peroxide at this rate here, which is 3.67. As we can see, step number 2 has got a faster rate because 3.67 times 10 to the power 24 compared to 4.55 times 10 to the power 22, this is a bigger number. Okay. I know this is one mistake I saw some of my students making. They ignored this scientific notation part, right? Or they did not know how to interpret this part here. So if you're saying 3.6, they just looked at this 3.67 compared it to 4.55 and said, oh, 4.55 is bigger than 3.67. It doesn't work like that, because this one has got 2 additional zeros. Okay, this one has got 22 zeros in front of 3.67. This one has got 24. It's just like saying 5 times 10 to the power of of 2, and maybe saying 3 times 10 to the power of, let's say, 5, right? Okay, because this has got more zeros. So this one is going to be 3, 1, 2, 3, 4, 5, and this one is going to be 5, 1, 2. This is just 500. This one is actually 1, 2, 3, 300,000. So this one is a bigger number. But if we just look at this, we might be tricked to think that 3 times 10 to the power 5 is smaller than that. I bet you this actually happened. Some of these things I share with you, I see that in class. And as a teacher, I try to figure out where the problem is. And I always want to warn some other people. Probably right now, as you are watching this video, you'd have made the same mistake. So this one here, 3.67, is bigger than 4.55. Now, let's take a look at what we have. The only source of iodate ions for step 2 comes from the reaction in step 1. Okay, so this here, the iodate ions must be produced from step 1. So whatever is produced in step 1, the iodate ions are then passed on to step 2. So which means step 2 depends on how step 1 performs. Which one of the following statements identified with justification the rate determining step? Okay, now this is not something that's explicitly stated in the syllabus. Like I've said here straight up, let's start off by looking at the syllabus point. I couldn't find a syllabus point specifically referring to this question. Probably, I didn't read the syllabus well. If anyone comes across a syllabus point that specifically states this, then just let me know. My thinking is this is the implied part as part of applying critical thinking to solve non-standard question. This is a non-standard question. You can use critical thinking, which most of my students always know that I would always shout out loud, please, when you get in the exam or in any assessment, just let common sense prevail where necessary. This is where you could use common sense. Now, let's take a look at what the examiner had to say about this one. 41%, which is less than satisfactory pass rate. So 41% of candidates got this question right, only 41%. But anyway, let's see what the examiner thinks about this. The examiner went on to say candidates had to identify the rate determining step in a 2 reaction sequence, and given the relative rates of consumption consumption of reactants in both equations. The reason why it was the rate determining step, okay, many of the candidates chose the alternative A, which stated the reason that it was the first step in the sequence, while 40.7% of the candidates selected the correct answer C with the reason that it was the slowest reaction. This indicates many candidates did not understand rates within a multiple sequence of the reaction. Okay, anyway, what the examiner is just trying to say here, I'm going to explain it using this one here, this diagram I've got, or this, I don't know, it's a picture, you know, I got it from Google Images. It's from WikiHow. Thank you, WikiHow. I'm going to acknowledge you for this one. You are helping young people with this year, because if you hadn't put this out, I wouldn't have had a good prop here to explain my point. Now, let's take a look at this here. In 2012, okay, I like stories. In 2012, Jamaica actually set the world record for the 4x100 relay, which is 36.84 seconds. Now, if I take the average here, I know we might disagree. The sequence of, I remember there from top of my head, this was, I think it was, this was Blake, not I think, this was Blake right here running this leg, and this was Bolt. And I can't remember, was this Carter, or this was Freighter. This was the team that actually won this. I think I'm now confused on Carter and Freighter who came first, but it's neither here nor there because it's not really essential to what I'm trying to say here. But we know that if we take a look at this 36.84, if we take an average, I would say if we divide by 4, on average each team member ran about 9.21 seconds of their leg. Okay, so they were running an average of 9.21 seconds. Let's just say, you know what, the Jamaican team coach had an epiphany, and he decides to invite Wengesai, and that's me. Okay, he decides to invite Wengesai to say, Wengesai, you've got good chemistry, no pun intended, with the team, and we want you to run the second leg of this one here. And lo and behold, Wengesai runs his record, which is superb, by the way, which is 30 seconds. Okay, right. We know, let's just say, okay, Bolt is going to run his good 9.21, Carter is going to run his good 9.21, and Blake is going to run his good 9.21. I know that, of course, someone would debate to say, no, they did not. I understand when they ran this. We know that Blake actually killed this. Blake did this for me. Of all the team, I know Bolt gets the credit for this, but Blake is the one who recovered from Jamaica being second in the race. America was just leading, and then Blake really overtook and ran a good leg there. So Blake did it for me on this one. It's neither here nor there. Let's talk about chemistry. We might talk about sports some other time. Now, so what we're looking at is these guys are going to run this, and Wengesai will come in with his whopping 30 seconds here. Instead of this time being 36.84, it's going to increase. It's going to be more than 36.84, because if you say 9.21 times 3, if we take 9.21, multiply that by 3, it's going to give you 27.63, yeah, because this is 63, that's 27.63. This is what these three guys, Blake, Bolt, and Carter, are going to put into this race. And to that you add the whopping 30 seconds from Malangov, 7.563. Does it matter? Because Malangov's average is 30 seconds. If you decide to say, oh well, maybe if we change Blake and have him here and change Malangov and change the position of Malangov there, will it change the average time that this team is going to run? Obviously, I mean the overall time, not average, the overall time that the team is going to run. No, it's not, because who actually determines how much time they're going to run here? It's not the fastest guys, it's the slowest guy, which is me. So at the end of the day, the slowest step in this whole process will determine the overall time that the team is going to produce here. So in this case, if we look at the answers, we are looking at the fact that if step number 1 has got a rate of 4.55, it doesn't matter. Even if this here, we had another step here which produced iodine, where we could iodide ions. Let's say we had step number 1 where we reacted A with something that is with iodine, and it converts these to iodide ions. And let's say this rate here was maybe 4.89 times 10 to the power 26, right? Even if this is a very fast process, the iodide ions being produced here, and then we've got the iodide ion, this process here at 4.55 times 10 to the power 22 is going to slow down the process. It's not the fact that it's step 1 because it's the first step in the sequence. No, that's not correct. It doesn't matter if we move it to any position, as long this rate is slow, that's the rate, overall rate determining rate. Just like I was saying, you can move me anywhere to any leg to run any leg of this relay. Because I'm the slowest of this whole team, I'm going to be slowing everyone down, and the time I will affect the time it takes to run the race. So B, step 2, because it is the last step in the sequence. No, it doesn't matter. Obviously, step 2 will actually make things quicker slightly, but it doesn't matter. Step 2 is not the rate determining because it's the fastest. Now, step 1, because it's the slower step in the sequence, which is, this is our correct answer right there, because we've already mentioned that. You already know that by now, hopefully, that C is the correct answer. Step number 2, because it is the faster step in the sequence. No, it's not the faster step. I know some of my students who picked this. These are the students I was saying they did not realize that this is times 10 to the power 22 and this is times 10 to the power 24, which means this is a bigger number. They just looked at the absolute 4.55 and 3.67. I know I had students who picked D as the correct answer when I did put this up on the board for the class to solve. Anyway, I'm going to finish off this one here, and I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.